Good afternoon, everyone. Today, this is my final project presentation of Spatial Systems Science, and my project is about the coastal elevation change analysis at Malaquite Beach using repeated mobile LiDAR surveys and DEM of Difference. And my project co-authors are Dr. Michael J. Starek and Jacob Berryhill from the Mantis Lab. So this is the study area which is shown the map, like the image is the Malaquite Beach of the Padre Island. We did the survey using mobile LiDAR and the DEMs were created using that. And the survey dates were 2 times a year from 2022, 2024 and 2025. The analysis was limited to the common extent, and these are the vertical and horizontal coordinate systems. And the DEM it has the 10 centimeter resolutions. So the workflow starts with the DEMs were created using the mobile LiDARs survey, and the common extent has been clipped out of all the 4 timelines and then aligned using the snap raster, and the cell size set it in the environment, and the TEM RMSE as calculated using the topo points, and the base station and RTK uncertainties were calculated separately and uh, propagated through the DEM RMSE, and generated the whole uncertainty propagation, and then use that for the level of difference threshold for the each DEM differencing of maps. And using those, we have separated the volumes of erosion and the volume of accretion, got the volume calculations, and the core and envelope and range products are the products of DEM time series. So these are the three LOD threshold maps that we created for the 4 timelines or the 3 DOD analysis, where the uncertainty elevation levels has been removed so that the accuracy stays much more better. And the from this three, you can see the red area is the accretion that showed all over the 3 maps, and blue is the erosion, and the white is the below the threshold of uncertainty. And the first DOD map, LOD map shows the much more accretion, and the LOD2 shows the much more accretion on the dune system, but uh, the shoreline has been shifted much more in LOD map 3 here. So when it comes to the volumetric analysis, the all three time intervals show net volume change. The beach gained sediment in every period. The largest gain was in first interval at over 23,000 and cubic meters. By the third interval, it dropped to 8,600 cubic meters. So the DEM time series analysis using cell statistics. Like we use the cell statistics to generate the core map, which shows the minimum elevation at a cell level uh, over the 4 timelines, and the maximum elevation at cell level across 4 timelines will be used for the envelope map creation, and the range is from the variability in the timeline, variability of elevation at each time over the timelines. So here the limit. This is the map that we created using the local scene, using range and the elevation range as a map, and elevation is a elevation surface is the envelope map, and all intervals showed net accretion, and the net volume has been decreased over the years. The core envelope and range map showed the uh, elevation variability over the years, and the limitations were the June results were not as much as trusted because of the slow vegetation and low point density, and the RTK points where observations were shorter than it was 5 seconds when it compares to the ASPS standards. And maps shown, maps are shown very small maps because the area is so much more. Thank you.